Today we'll be discussing propagation of sound. Sound is a wave motion which is conveyed through an elastic medium from a vibrating body to a listener. Propagation of sound. Sound is a form of wave motion which is conveyed through an elastic medium from a vibrating body to a listener. Gases, liquids, and solids can all transmit sound waves, but a vacuum cannot. Sound produced by sources are longitudinal wave. That is, it is a form of energy which moves in such a way that its direction of motion is parallel to the direction of oscillation of the molecules of the medium. The study of sound wave is very important because we make use of sounds in our everyday life. As we talk, as we listen, as we play musical instruments. And this will lead us to the next subheading, transmission of sound waves. How sound is being transmitted. Transmission of sound waves. Sound waves travel as a series of compressions and rarefactions. Air, being highly elastic, expands, and in doing so compress the layer of air next to it. In this way, the state of compression is passed on and spreads rapidly outwards in much the same way as ripples spread out over the surface of water in water wave. Sound is therefore a compression wave. The sensation of hearing results when such waves strike the ear. Sound waves can travel through solids and liquids as well as gases such as air. Sound waves can travel through solids, can travel through liquid, can travel through gases, but they can never travel through vacuum. Experiments to show that sound does not travel through a vacuum. An electric bell is put inside an airtight jar. This is the jar. The airtight jar is connected to a vacuum pump, as shown in this diagram. The electric bell is then operated and set ringing. As air is gradually pumped out from the jar, it is observed that the sound from the bell gets fainter and fainter, though the hammer is still striking the bell. No sound is heard when all the air in the jar is evacuated, although the hammer is still striking the bell. Sound is again heard when air is reintroduced. This shows that sound cannot be propagated in a vacuum, but requires a material medium for transmission. Speed of sound waves. The speed of sound is found to depend on the density and elasticity of the medium. Wind will also affect the speed of sound in relation to a listener. For example, the speed is increased if sound travels in the same direction as the wind, and decreases if the sound travels in opposite direction. Sound has speed. For example, the sound has so much speed as much as 332 meters per second. The speed of sound in water is as high as 1,500 meters per second. And also a steel rod can have a speed sound as high as 500 meters per second. If you get a cylindrical tin and you get a rubber tin and you are able to strike both of them, you discover that the cylindrical thing will be able to make more sound. Why? Because of the density and elasticity of which that material is made. Example, which of this medium have the greatest speed of sound? A. Water. B. Steel rod. C. Air. D. Wooden rod. And the answer is water. Why? Because it has almost about 1,500 meter per second speed of sound. For air, you have about 332 meter per second. For steel rod, it can be as high as 500 meter per second. And for wooden rod, you will agree that this one will produce a lesser sound than for a steel rod. So the real answer is water. Example 2. If sound travels in the same direction as the wind, the speed of sound will also dash. A. Decrease. B. Remain the same. C. Increase. D. None of the above. And the correct answer here is this. If sound travels in the same direction as the wind, the speed of sound will also increase. Why? Because wind also affects sound speed.